Let's start new lesson. Lesson outcome number 3. Determine flow depth, Y. Based on flow, Q. Using Manning equation. In previous lesson, we can calculate or determine flow Q in open channel based on flow depth, Y. Using the Manning equation. Today, we are going to learn how to determine flow depth, Y. Based on flow, Q, using Manning equation. The approach to determine the depth, Y, is by trial and error approach. Why do we need to use the trial and error approach? Let us look at one example problem to determine Y. Problem number 1. Determine flow depth, Y, based on flow, Q, in rectangle channel. For problem number 1, calculate the water depth in an open channel to convey flow Q, 10 meter cube per second. With Manning coefficient N is 0.014. Channel slope S is 0.0004. And channel width is 2 meter. Emphasis again. We are going to determine the water depth. The base width is 2 meter. To solve it, we are going to approach as in lesson outcome number 2. But here, the depth Y is unknown, so we replaced Y is equal to variable Y. To calculate flow Q, first, we need to calculate the area A. The area A is width B multiplied by depth Y. The B is 2 and the Y is Y. Thus area A is 2Y. The hydraulic radius R is area A divided by wetted perimeter P. Wetted perimeter for the rectangle is 2 plus Y plus Y. Thus total wetted perimeter is 2 plus 2Y. The hydraulic radius R become 2Y divided by 2 plus 2Y. Replacing the value of A, R, S, N, and Q into Manning equation. We have numerator 2Y multiply 2Y power 2 over 3. And we have denominator 2 plus 2Y power 2 over 3 and other calculation. The numerator 2Y multiply 2Y power 2 over 3. And denominator 2 plus 2Y power 2 over 3 is complex to solve for depth or variable Y. The Y cannot be solved directly. To get the flow Q to become 10, we have to do trial and error approach on the depth of Y value, so that the result calculation of flow Q is 10. Let's start the trial and error approach. To determine depth, Y, in rectangle channel. The calculation of flow Q is by start writing down the formula of Manning equation. Then, assign all known values, such as the channel slope S, roughness N, bottom width B. Then, start trial depth Y at 1. Replacing depth Y to 1. We can start calculate the area A, wetted perimeter P, hydraulic radius R, and flow Q. The area A, after calculation, A is 2. The wetted perimeter P, after calculation, P is 4. The hydraulic radius R, after calculation, R is 0.5. Then N1 is equal area A, so N1 is 2. N2 is equal hydraulic radius R, power 2 over 3, the N2 is 0.62996. N3 is equal slope S, power 1 over 2, the N3 is 0.02. Lastly, the flow Q, after calculation, become 1.79989. This flow Q, 1.79989, it is not 10, the target value. Thus, we need to try again with another flow depth y. Now, try the depth y is equal to when the depth y is 2. The area A, after calculation, A is 4. The wetted perimeter P, after calculation, P is 6. The hydraulic radius R, after calculation, R is 0.66667. Then N1 is equal area, A, so N1 is 4. N2 is equal hydraulic radius R, power 2 over 3, the N2 is 0.76314. N3 is equal slope S, power 1 over 2, the N3 is 0.02. Lastly, the flow Q, after calculation, become 4.36082. This flow Q, 4.36082, it is not 10, the target value. Thus, we need to try again with another flow depth y. Now, try the depth y is equal 3. When the depth y is 3. The area A, after calculation, A is 6. The wetted perimeter P, after calculation, P is 8. The hydraulic radius R, after calculation, R is 0.75. Then N1 is equal area, A, so N1 is 6. N2 is equal hydraulic radius R, power 2 over 3, the N2 is 0.82548. N3 is equal slope S, power 1 over 2, the N3 is 0.02. Lastly, the flow Q, after calculation, become 7.07556. This flow Q, 7.07556, it is not 10, the target value. It is almost close to 10. Thus, we need to try again with another flow depth y. The better approach to calculate flow Q, repeatedly, is by using Microsoft Excel. Let's put the calculation in Excel. Remember, we already done calculation of flow based on depth, in our lesson outcome, number 2. First, put title in row 2. Let's type S, N, B, Y, A, P, R, N1, N2, N3, and Q. In row number 2, starting column B. In third row below title S, type 0.0004. Below title N, type 0.014. Below title B, type 2, and below title Y, type 1 as initial guessed for depth of flow. After that start, put formula in A, P, R, N1, N2, N3 and Q. N1 is equal A, N2 is equal R power 2 over 3, N3 is equal power 1 over 2, and Q is N1, multiply by N2, multiply N3 and divide by N. The result of calculation, after you put the formula, will be as above. The flow Q calculated is 1.79989. Since the result for Q is not 10, try another number, for depth y. Change the depth y to 2, by typing 2 under title y. Automatically, you will see the result of flow Q is 4.36082. Since the result for Q is not 10, try again. Try change depth y with 3. Automatically, you will see the result of flow Q is 7.07556. The result for Q is still not 10, try again. Try change depth Y with 4. Automatically, you will see the result of flow Q is 9.84884. The result for Q is still not 10, try again, but close to 10 already. Now, try change depth Y with 4.1. Automatically, you will see the result of flow Q is 10.128. The result for Q is slightly above 10, it is close to 10. Now, try change depth Y with 4.05, which slightly less than 4.1. Automatically, you will see the result of flow Q. Now, Q is 9.9884, which is 10.0 in 1 decimal point, or 9.99 if 2 decimal point. This result is more than good enough in our estimation of depth of flow. The answer depth Y for the problem is 4.05 meter. This result of flow Q, 10 meter cube per second, is the same as in lesson outcome number 2, where depth Y is 4.05. Alright. If you calculate manually, with trial depth Y is 4.05. The calculated flow is 9.9884. The same in the Excel. How to put your answers in test or exam papers. For trial and error approach to find depth, Y. See the next 2 slides. How to put your answers in test papers. In your test papers, put your answers as below, with initial trial depth. Also, in your test papers, put your trial and error calculation in a form of table, as below. But, don't waste too much time finding the most correct answer during test. Just put 3 or 4 lines of answer is enough. Take note, the term flow depth is also called as normal depth. Later, you will learn to find depth in best channel cross-section design. Also, you will learn to find critical depth in flow type and in non-uniform flow. So there are 3 depths that you will learn in this course. That's why you must be aware of the terms regarding to depth. Another approach in selecting depth Y in the trial and error. First, try initial depth Y equal to 1, if calculated Q is small, then try depth Y equals 10. Second, try depth Y equal to 10, if resulted calculation of flow Q is high, try in between 1 to 10, which is 5. Third, try depth Y equal to 5, if calculation of Q is close to 10 but higher than 10, try 1 less than 5, that is 4. Fourth, try depth Y equal to 4. Fine-tune the depth Y until flow Q is 10. Lesson outcome number 3. Determining depth Y based on known flow Q for rectangle channel is finished. Next lessons, more example problems for different cross-section. This presentation note was created by using Speaking Presentation for PowerPoint, SPFP, a tool to create self-speaking presentation with computer, human-like voice.